what we're going to do today is to, we'll try to do it together, that I'll also ask questions and try to get answers, to see, as was just said, to see how math and Torah can unite, can join together. In mathematics itself, the most important thing that has to be understood as together is what's called algebra and geometry. Geometry is forms. We're just now going to speak of plane forms, meaning in two dimensions, like squares and triangles. Algebra is using notation like n squared, or we'll do different very, very simple equations using algebraic, you know what it means, the algebraic expression. But if I write, just a simple example, if I write n squared, so a person that knows algebra, so n squared is, if n happens to be 2, so 2 squared is 4, or 3 squared is 9. But not always does a person picture in his mind, when he sees this expression, this simple expression of n squared, does he identify that means actually a square. Like if it's 2 squared, it means 1, 2, 3, 4. But the most important thing to realize and to learn to think is to identify an algebraic expression with a geometric form. This is the basis of understanding mathematics in a way that it will apply to different topics in the Torah. To analyze a pasuk, a verse in the Torah. Because in order to analyze a verse, you have to say how many letters the verse has. So if it has a certain amount of letters, maybe it's a square number. If it's a square number, it means that you can write the verse as a square. Let's say there's 16 letters in a verse. So 16 is 4 squared. So if I immediately know that a square should actually be thought of as a square, as 4 by 4, so it means I can write the verse 4 by 4. And maybe if I write the verse 4 by 4, I'll see that maybe the 4 corners form a word by themselves. Or all different types of phenomena that I would not at all recognize or know of if I didn't identify the number of letters or the number of words first as a expression, that it's a square, it's a triangle. I'll now explain what a triangle means. And then give the verse that form, and then try to just observe, to look and understand what different allusions or hints, remazim, can appear when the verse is given that form, or the text is given that form. Right. This is just an introduction. The two most basic forms are the triangle and the square. The reason I began with the square, because this algebraic expression is much more familiar with us. That we should all know what n squared means. But a triangle has a different expression to it. Instead of n, I'll still use n. N times n plus 1 over 2. This in mathematics is called a triangle, a triangular number. So this is, you understand what this means? Let's say n is 3. So what does this expression give you?
10.
No, if n is 3, it's 3 times 4 over 2. What? So what is 12 over 2? 6. 6 is the triangle then of n, of 3. How is 6 the triangle of n? Because 6 is 1. Just think of dots. If I have a triangle that each side of the triangle is 3 dots, it means 1 plus 2 plus 3 is 6. There are 6 dots here, right? So 6 is called the triangle of 3. What about the triangle of 4? It's simply to add another line. So what's the triangle of 4? A triangle means the sum of all numbers from 1 to that number. That's what a triangle means. From 1 to 5 is the triangle of 5. What's from 1 to 5?
15.
15. From 1 to 7 is the triangle of 7. How much
28.
is 1? 28. How many, what's the first verse in the Torah? The first pasuk? Bereshis bara Elokim es hashamayim v'ha'aretz. How many letters does it have? 28 letters. Meaning that the verse can be written as a triangle of 7. That the big base is at the top, and then you just keep adding letters. Adding here points, but they're letters. And then the last line has 7 letters to it, which is, what are the 7 last letters of Bereshit, of the first pasuk? Bereshis bara Elokim es hashamayim v'es ha'aretz. So what would be the bottom line? V'es ha'aretz. And the earth, that's the bottom line. Those 7 letters are the bottom line of the triangle. When the verse is written this way, many, many amazing and beautiful things appear. But this is just to understand that a triangle means the sum of numbers from 1 to that number. And the expression for it is this. Meaning that if I want to know what is the triangle, meaning the sum of all numbers from 1 to 26, let's see who can figure it out. If n is 26, I want to add, 26 is the value of Hashem's name. I want to add all numbers from 1 to 26. 1 plus 2 plus 3 plus 4 to 26. And I want to immediately know what that is going to give me. Right, you don't have to add them all. Use the formula.
26 times 26 plus 1 over 2.
What number?
216.
No.
301?
No. 26 times 27 over 2. When is 26 times 27, how much?
Do that again. Multiply 26 times 27 and then divide by 2. Simple math.
Yes.
1,444.
351.
What did you say?
1,444.
No. 351, that's the correct answer. 26 times 27 over 2 equals 351. So this number 351 is the triangle of 26. Now, the triangle is actually the most basic geometric form, even before a square. It's just once more, a square is much more simple to express. N squared. This is a little bit more, seems a little bit more complicated. But there's a very, very simple, this is our number one equation to understand the relation between triangles and squares. Here I wrote a square of 4. 4 squared is 16 points here, because it's... Who can see, is this squared a combination, a sum of triangles? But I want to try to see that this square is actually 2 triangles put together. Who can see how there are 2 triangles here put together? And what
You split it down the middle with the triangle.
Correct. If I split it exactly down here, so what do I have? What happens? What is this triangle? This is 1 plus 2 plus 3 plus 4. So that's 10 points. And that's the triangle of what? No. If it goes to 4, so it's the triangle of 4. And this, now I have 1, 2, and 3. So what's that the triangle of? There's the triangle of 3. So what do I see from this form? I see that the square of 4, 4 squared, equals triangle 4 plus triangle 3. Now, when a person studies math or anything which is logical, you have to try to abstract, to generalize. Who can tell me what is the general principle that we see here? I want to know the 26 squared. So just from looking at this, I can understand that 26 squared must be the sum of two triangles. What are they?
26 and 25?
Exactly, that's correct. 26, let's do it together. 26 squared equals 676. Before we said that we'll now use this notation. This is instead of using this, we'll use a simple notation. That this triangle means a triangle of a certain number. The triangle of 26 is all numbers from 1 to 26, which before we saw to be equal to 351. Now let's look at the triangle of 25. This you can just figure this out by taking this number and subtracting 26. Because the triangle of 25 is all numbers from 1 to 25. And the triangle of 26 is all numbers from 1 to 26. So just if you take off 26 from this number, so that's 325. How much do these two numbers equal together? 676. So what did we see? We just, again, if a person would not visualize the geometric form, you would never just immediately see this phenomenon to be true. But just from looking at this, one can immediately see that a square is a construct form. It's a construct of two triangles. The triangle of itself plus the triangle of the previous number. Now let's prove it. Let's see if we can prove this. But we just now we're taking geometry and now going back to algebra. I hope this is not too much. What we said now is that n squared equals the triangle of n, which is n times n plus 1 over 2, plus the triangle of n minus 1, which is n minus 1 times n over 2. So if it's true what we just said, we have to see that this is an equation. It's an identity. Do you know how to do this? Each one of these expressions has to be opened up, and then it all has to reduce to n squared. What is n squared? N squared is n times n. Do you kids know how to do this?
Yes.
Right. What is this? N times n plus 1, just the top. But if I want to open this up, how do I write n times n plus 1? N squared plus...
That they may not know.
No, it's n squared plus n.
They haven't gotten to that yet.
All right.
Trivial properties.
N squared plus n over 2. And this is n squared minus n over 2. Right? If you haven't learned this yet, you just believe. So if I want to put it together, what happens? What do I get here? I get 2n squared. Here there's a plus n, and here there's a minus n, so that cancels out. And it's all over 2. What is 2n squared over 2? N squared. Right, so that, now I just proved this equation to be true. That n squared equals the triangle of n plus the triangle of the number before n. But again, this is algebra, and this is simple visual geometry. That from here it's apparent. And that's very important to develop the thinking, the mind, and to be able to once more to begin to apply this to phenomena in the Torah. It's most important to know that all algebraic expressions have their geometric parallel to them. Okay, now we're going to give some examples, basic examples from the Torah. But the first question is, can anyone think, or I'll ask in general, is it possible that a triangle can itself, the number of dots in a triangle can be rearranged to become a square? Means that the same number is both a triangular number and a square number. What's an example? Who can tell me a number that is both the sum of all numbers from 1 to some number, and it's also a square of a number? It's not so easy. It's not so hard, but it's not so easy either.
Conceptually, they understand.
Because I want something that's both a triangle, and let's say that these dots are coins. And I can take these coins and I can form either a triangle out of these coins, an exact triangle, or I can rearrange the same coins and it becomes an exact square. And so let's go through the triangles and see if it's possible. I'm now assuming that we already can recognize square numbers. Let's go through the new concept that we learned today is a triangle. You have one already?
3.
Now, what is the triangle of 3? 1 plus 2 plus 3 is how much?
6.
Is 6 a square number?
You have to come up with a square number when you add your triangle.
You had all the numbers together have to now become a square number. 6 is not.
Number and see if you can apply it as a triangle.
6 is not a square number. So once more, one triangle is 1. The first case is a trivial case, that the number 1 is both the triangle of 1 and it's also the square of 1. But that's trivial. The triangle of 2 is 3, that's not a square. The triangle of 3 is 6, it's not a square. The triangle of 4 is 10. Everybody knows that 10 is a very important number. Ha'asiri HaKodesh Hashem. It's the holy number of the Torah. There are 10 commandments. Hashem created the world with 10 sayings. There's the concept in the Torah of 10 sfirot. In the soul, there are 10 powers of the soul. In the Zohar it says that 10, what's so important about the number 10? Why is 10 such a special number? It's called a simple song, a double song, a triple song, and a quadruple song. Shir Pashut, Shir Kaful, Shir Meshulash, Shir Merubah. Meaning that what's important about 10 is that it's simply 1 plus 2 plus 3 plus 4. It's the triangle of 4. Just like Hashem's name, Yud Kei Vav Kei, has 4 letters to it. So if I write just the first letter by itself, Yud, and then I write 2 letters, Yud and Hey, and then 3 letters, Yud and Hey and Vav, and then all 4 letters together. So how many letters do I write all together? 10, because that's the triangle of 4. That's called the simple song, and the double song, and the triple song, and the quadruple song. That's the terminology for this. All right, so now, but 10 it's a triangle, but it's not a square. What about 5? We said that the triangle of 5 is 15. Is that a square number? No. What about 6? What's the triangle of 6? 21. Is that a square number? No. 7, we said before. We're getting there.
20.
Is that 28? Is 28 a square number? No. What about 8?
36 a square number?
Is 36 a square number?
Yeah.
What is it?
8.
It's
6.
6 squared. So there we got it. That the first significant example of a triangle that can be converted into a square, and vice versa, is the triangle of 8 equals the square of 6. So if we just use our simple notation, we write like this: the triangle of 8 equals 6 squared. This is, once more, just simple notation instead of having to write 8 times 9 over 2. So I'm just saying this is the triangle of 8, means all numbers from 1 to 8. 1 plus 2 plus 3 until 8 is 36, but that itself is a square, 6 squared. Until the triangle of 8, there's no example of this, except for the trivial example of 1. Who can think of when this phenomena appears in the Torah? It has to do with a certain holiday. That's the hint.
Rabbi Ginsburgh means the phenomenon
Of
of 36.
36. That 36 is first a square, as first a triangle, of 1 and 2 and 3 and 4 until 8. And then, as soon as you reach 8, then it becomes a perfect square.
What about it?
What's that?
What's about 36? What is 36?
No. There are 8 days of it together, which means there's 8 days. But something that actually we do it physically. The first day that we have 1, and then the second day there's 2, and the third day there's 3. And if you have to go to the store and buy these things, so you have to buy at least 36 candles without counting the shamash.
There's a question of it.
Right?
That's not in Torah.
It's the 620th mitzvah. There's 613 mitzvot in the Torah and 7 mitzvot of the Rabbanan. The last one that also includes all of them is the mitzvah of Chanukah. It's the last of the 7 mitzvot of Rabbanan. That's certainly the Torah. There's Torah Shebichtav and Torah Shebaal Peh. So once more, Chanukah is a perfect example of adding from 1 to 8, and then at the end, all of a sudden, seeing that the triangle is a square. Who remembers something in the Torah about 36? When you say 36, what does 36 bring to mind?
36 tzaddikim.
Right? 36 tzaddikim in the generation. It says that every candle that we light on Hanukkah, a candle is a soul. Ner Hashem Nishmat Adam. Every candle is a soul of a tzaddik, and there are 36 candles. So if I think of the triangle from 1 to 8, meaning that the first candle is at the top of the triangle. That's like the tzaddik yesod olam, the chad bidoro, the one of the generation. And then there are 2 under him, and 3 under him, and 4 under him, and 5, and 6, and 7, and finally 8. So that's the way that we performed the mitzvah. It takes us 8 days, not 6 days. 8 days, each day we're adding another candle. So what we've constructed the triangle of 8. But having now come to the conclusion of the triangle of 8, I've reached a number which can be rearranged to be the square of 6. The square of 6 has different aesthetic properties to it that the triangle of 8 doesn't have. The triangle of 8 appears to be that, as we said before, that there's one tzaddik here at the very top, and then it descends. But if I construct this, rearrange this to be a square, so a square represents in a certain way that there's equality, that they're all the same. A square doesn't necessarily have a top point to it. Who remembers the machloket between Bet Hillel and Bet Shammai? How to light the...
The Hillel says you want like one person enters the simple builds up, and then the 8th night of the Sumha goes up. The Shammai says by human nature the simple goes down after one night. It's a big thing, but that's the last thing. So you light 8 the first night, then it goes down.
Right. The fact that you said that it's human nature, that's one explanation. There's a different explanation of Beis Shammai. That's one nice explanation. In any event, Beis Hillel says that we begin from 1 candle and we increase all the time, from 1 to 2 to 3 until finally we reach 8, the final day. But Beis Shammai says the opposite, that we begin with 8 and then we descend until 1. What's the difference geometrically between a triangle and a square? Even though a triangle is in a certain sense simpler than a square, because we said that a square is a construct of 2 triangles, but a square is much simpler in the sense that if I turn it in 90 degrees, it will remain the same. It always will appear to be the same if I turn the square around by 90 degrees. But if I turn this over, so a triangle, for instance, if I said that Breshit has 28 letters to it. So if I begin at the top with Bet, the bottom line is the 7 last letters, Vet Haaretz. But a triangle can be written in an opposite way. I can begin with 4, say the triangle of 4. Who remembers in a book, did you ever see at the end of a book, in old books, the way they're printed, that the last page, when you have to just conclude the last few words of the page, so it's done something like this. You have a line, say, of 4 words, and then 3 words, and then 2 words, until finally 1 last word by itself. That's a triangle. But it's a triangle going down, reducing it. That's a Beis Shammai triangle. That's more. A triangle like this is a Beis Hillel triangle. This, of course, means that we're always reading. The human mind reads from top to bottom. Because I could say that Beis Hillel is just looking at this same triangle. Just that Beis Hillel is looking at the triangle from top to bottom, and Beis Shammai is looking at it, without turning it around, is looking at the same triangle from bottom up. But that's not the way the eye reads. The eye reads always from top and down. Therefore, Beis Hillel reads the triangle, visualizes the triangle this way, and Beis Shammai visualizes the triangle this way. So that's something about a triangle that a square doesn't have. Much more, a square has much more equality to it than a triangle, even though geometrically a triangle precedes the square. All right. So we see that this phenomenon of a triangle becoming a square appears on Hanukkah. There's one other time in the year that this phenomena appears. And the fact that there are two edim, two witnesses to the same thing, is a sign that this is really what the Torah had in mind, intended. Now this is a little bit more difficult. On Hanukkah we add every night another candle. Who can think of another time in the year that we're adding from 1 to 2 to 3 to 4? That we're constructing a triangle. What other time in the year is that? That the first day it's 1, and the second day it's 2, and the third day it's 3.
Sphira?
Right, Sfirat HaOmer. Now I'll see if you really understand. Who says that Sfirat HaOmer is the second day is 2? Maybe the second day is just the second day. Once more, if I have the week, there are 7 days in the week. It doesn't mean that the second day is 2 days. It's just the second day. Right. If the second day would be just the second day, how would I say it? Hayom Yom Sheni Lo. Then it would just be the second day. But we don't say Hayom Yom Sheni Lo Omer. How do we say it? How do we say Sfirat HaOmer? Hayom Shnei Yamim Lo Omer. What does that mean? It means today is 2 days. It's not the second day. We say that today is 2 days to the Omer. How do we say the third day? We don't say Hayom Yom Shlishi Lo Omer. We say Hayom Shlosha Yamim Lo Omer. Today is 3 days. So what we're saying that we want to create a triangle. It's not just a series of numbers, 1, 2, 3, 4. We're adding. Every day we're adding the next number to the previous days. So how many days do we count? We count 49 days. So how many have we really counted? Because on the 49th day we're saying, we don't say today is the 49th day, we say today is 49 days. So we have, actually what we've done is we've counted all numbers from 1 to 49. 1 plus 2 until 49. How much is that? Let's do it. Let's figure it out. Let's figure it out. What was the formula? How do we do it? I want to do the triangle of 49. So what does that equal? It equals, what did we say before? It equals 49 times 49 times what? Over what? 49 times 50. We don't count the 50th day, but here we see that 50, Tisbru Chamishim Yom, that the 50 appears in the formula. We don't count it, but it has to appear here. Because the formula says, the expression is 49 times 50 over 2. What does that equal?
It equals 1,000.
Right, 1,000, how much? 200?
1,225.
Exactly. Very good. Excellent. 1,225. So actually in Sfirat HaOmer we count 1,225 days. You think you're only counting 49 days, but actually you're counting 1,225 days. Now probably no one knows, is this a square number?
Yeah.
You have to have a calculator to see if it has a square root to it. This is a square number. It's 35 squared. 35 times 35. So what do we see here? we see that the triangle of 49 equals the square of 35, which is the exact same phenomenon that we saw before about Hanukkah. That we had an additive series, which means we created a triangle, and when we reached the climax, the consummation of the triangle, so it all now became a square. Is there any number between 36 and 1,225 that has this same property? So obviously you can't know this.
35.
No. See. 36 is the first significant number after 1 that is both a triangle and a square. Now we've seen that there's another number that has the same property to it. That it's both a triangle and a square. It's the number 1,225, which is the triangle of 49, and it's also the square of 35. So the question is, do you think that there could be another number in between 36 and 1,225, that is both a triangle and a square? And the answer is no. There's no number in between. From 36 until 1,225, there is no number that is both a triangle and a square at the same time. So the fact that there are two periods in the year, in our Jewish year, that manifest this property is a very, very amazing example of Al Pi Shnei Eidim Yakum Davar. That this is what the Torah has in mind. That we're adding, but when we come to the climax, to the consummation, the conclusion, it all becomes a square, which means it all converts into a state of equality. That first there was hierarchy. A triangle has the property of hierarchy to it. What does hierarchy mean in English?
One thing is one
One.
higher than the other.
Right, so we begin with a state of hierarchy, and we reach a certain point that it becomes convertible into a state of equality, which is the relation between a triangle and a square. Right, so now, we'll write it in a certain. What?
There's going to be another class coming in.
Okay, we'll just finish right now. We'll do it like this: A, B, and C. If A equals 1 and B equals 1, so the triangle is also 1. The triangle and the square is also 1. So it's all 1. But if A equals, we'll say that this is the triangle of a certain number, and this is the square. We'll now write the square like this. This is a square of a certain number, and this is the number itself. The triangle of 1 equals the square of 1 equals 1. The triangle of 8 equals the square of 6 equals 36. The triangle of 49 equals the square of 35 equals 1,225. And there's nothing in between. So now the question, this is homework. If one can see the secret, this is a secret. The secret of what is happening here, so one could be able to predict the next time. Because obviously there could be infinite times that this will happen, from 1 to infinity. Once more. The triangle of 8, this is Hanukkah, and this is Sfirat Omer. that the triangle of 8 becomes the square of 6, and that's 36. The triangle of the Sfirat Omer, the triangle of 49 becomes the square of 35, and the number is 1225. I'll just write the next one. The next one is that the triangle of 288, does anybody know what that number represents in the Torah? 49 itself is a squared number, the 7 squared, that's the 7 weeks. 8 is one less than a square number. 288 is also one less than a square number. This is a double square. It's 2 times 4. This is 2 times 12 squared. There's a concept of 288 sparks in the world. That all of the Torah and mitzvot that we do is to redeem and to elevate these 288 sparks. Who elevates those 288 sparks? The tzaddik. What is this number 204? It equals the word tzaddik. The square is that soul that rectifies the triangle. In each one of these cases. That's the way it's explained in Kabbalah. What will be the number here? The next number after 1225. The simplest thing is 204 squared. 204 times 204. It's already a big number. 41,616. So these numbers really skip in big quantum leaps. These are the final numbers. The 36 is both a triangle and a square. This is both a triangle and a square. This is the next one. And then they get bigger and bigger and bigger. Now the question is, this is homework. If anybody can tell me by tomorrow, or as long as we're here for another week, what will be the next one to discover the rule. There's a rule here. And we see that this phenomenon and the rule behind the phenomenon is a Torah rule. Because it's engraved in the Torah, this phenomenon. It means that Hashem in the Torah wants us to know this phenomenon. Wants us to understand it. When hierarchy can be transformed and converted into equality. In mathematics, this is a deep mathematics. This is a recursive function, is the name for this. Stuff that you study in graduate school in math. But even without a recursive function, means that it has a recursive rule to it. But the theorem in mathematics is called Pell's theorem, which is not, if anybody wants to look it up. But even without knowing what Pell's theorem is and what the general rules for recursive function, if a person is bright, and everybody here is certainly bright, because all Yidden are bright, so just by looking at these numbers and trying to play around what's happening, by tomorrow you can come up with the rule. If you tell me the rule, then it'll be a siman tov. Alright, so this is like class number 1, to try to understand. What we did is that in mathematics itself, different fields have to be unified. The most important thing is to unify what's called algebra and geometry. And when algebra and geometry can be seen to be one, then it immediately begins to apply itself and to be reflected in different phenomena in the Torah, like this example that we saw right now. And then verses and texts can be analyzed based upon a geometric form. It's usually all symmetric geometric form. A triangle is symmetric, a square is also symmetric, but there are different symmetric properties.